All right, today we're jumping right into one of the absolute biggest questions in all science. We're going to use a really fascinating academic paper as our guide to go deep, deep into the mystery of dark energy and explore a wild potential solution called K-essence. Let's get into it.
So, it all starts with a question that just completely turned modern cosmology on its head. For the longest time, we all figured the universe's expansion had to be slowing down, with gravity pulling everything back together. But it's not. It's actually speeding up. Something is pushing everything apart, and we have no idea what it is.
Our guide for this whole deep dive is a master's thesis by Rupak Mukherjee focused entirely on K-essence. So what we're going to do is break down the key ideas from this paper to really get a handle on how scientists are trying to crack this massive cosmic puzzle.
Okay, so first things first, let's set the stage a little bit and really appreciate why this accelerating expansion is such a mind-blowing mystery. We are literally talking about a runaway universe.
Think about it like this. If you throw a ball up in the air, you expect gravity to slow it down, stop it, and pull it back, right? Well, scientists expected the exact same thing for the universe. But then, back in 1998, they were looking at these distant exploding stars, supernova, and saw something impossible. It was like throwing a ball up and watching it suddenly blast off into space, going faster and faster. This discovery changed absolutely everything.
So, the simplest idea scientists came up with was this thing called the cosmological constant. The idea is that there's this background energy woven into the fabric of empty space itself, and it's constantly pushing everything apart. But for the math to work, this energy has to have a very specific property, kind of like a pressure rating that physicists call an equation of state, and that value has to be exactly -1. Remember that number. It is the magic number we're hunting for.
But, just calling it a constant is really more of a placeholder than a real explanation. It basically kicked off this massive hunt for the true identity of this mysterious force, which we now just call dark energy.
And this is where the detective work really begins. Dark energy is just what we've named the culprit. The real challenge is figuring out what it's actually made of. And, like any good mystery, there are a lot of suspects. What's so cool here is the lineup of theoretical suspects. These are all different kinds of scalar field models. You can think of them as different types of invisible energy fields that could be filling the universe. The paper lists a whole bunch of them, from quiescents to phantoms, but it really zeroes in on one particularly promising candidate, K-essence.
So what makes K-essence so special? Why this one? Well, it doesn't just pop out of nowhere. It actually has roots in one of the most ambitious, most mind-bending areas of all of theoretical physics.
That's right. The mathematical engine behind K-essence is inspired by string theory. Now, that gives it some serious street cred, because string theory is our best shot at a theory of everything, a single framework to explain all the forces of nature. The fact that these two are connected suggests that the solution to the biggest mystery in cosmology might be tied to the deepest secrets in all of physics.
So the key here is what the K in K-essence actually stands for, kinetic. But hang on, this isn't the normal kinetic energy of, say, a moving car. The paper calls it non-canonical, which is just a fancy way of saying it's weird, it's different. It doesn't play by the normal rules of motion and energy. And this strange, exotic behavior is exactly what might allow it to create the anti-gravity effect we're calling dark energy.
Okay, let's dive into the model itself and see how this exotic form of energy can actually pull this off and solve the cosmic acceleration problem. This is where the theory gets, well, really beautiful.
Tucked away inside the K-essence equations is this one key variable. They label it x. The easiest way to think about it is as a cosmic dial. The value of this one single factor, which is all about the field's kinetic energy, basically determines the behavior of the entire universe.
And here's the payoff. The paper walks through all the math, but this table shows you the incredible result. If this kinetic factor, this x, is less than 2/3, the universe accelerates. But look what happens when x is exactly 1/2. That pressure rating, our omega, becomes exactly -1.
-1, the exact number we need, the number that the simple cosmological constant model requires. But the beauty of K-essence is that this number isn't just plugged in. It emerges naturally from the physics of its unique kinetic term. It's just so elegant.
So, to put it all together, K-essence gives us a dynamic mechanism. It's not just a random number someone pulled out of a hat. It's a field that can change and evolve. and under very specific natural conditions, it produces the precise effect we need to explain why our universe is flying apart.
Now, all of this sounds fantastic on a blackboard, but how does it actually connect to the real world? I mean, can we test this thing? Let's take a look at how this theory actually meets reality.
Because a physical theory is really only as good as its predictions, right? For K-essence to be a serious contender, it absolutely has to match up with the hard data we're getting from observing the cosmos.
And the good news is we have multiple, totally independent lines of evidence that all scream the universe is accelerating. These are the gold standards of modern cosmology. The data from those distant supernova, the faint afterglow of the Big Bang, what we call the cosmic microwave background, and even the way galaxies are clustered together across the universe.
And here it is, the crucial link. The paper confirms that when you take the equations of the K-essence model and you fit them to the actual real-world data from supernova observations, it works. The model is consistent with what our telescopes are seeing in the sky, which means it's a totally feasible explanation.
This quote from the paper itself really drives the point home. It points out that among this whole zoo of competing theories, K-essence really stands out as one of the most successful, especially when you consider its prestigious origins in string theory.
So, we're left with this really compelling picture. K-essence gives us an elegant, a testable, and a theoretically solid explanation for dark energy. But is it the final answer, or is it just one more clue, one piece of an even grander cosmic puzzle that we're still just beginning to understand? The hunt, for sure, continues.